All right, this is your crash course video, STAAR review primarily for chemical reactions and how to count atoms, talking about the law of conservation of mass and those sorts of things. Okay, so remember, the periodic table lists all known elements, but elements combine by gaining, losing, or sharing electrons. They combine chemically to form compounds. And then compounds and elements can undergo chemical reactions to gain or lose or rearrange atoms, not gain or lose atoms, but rearrange themselves and make new substances with completely different chemical properties than the substances that you had at the beginning. Okay, so a little bit of a review just on your basics. We're going to go over how to count atoms again one more time. And I just pulled an old practice quiz, and so we're going to start there. Let me get this out of the way. Okay. So question number 1 says, how many atoms are represented here? Well, how many individual atoms? Well, I have magnesium atoms, I have oxygen atoms, and I have hydrogen atoms. So I got to figure out how many of each one, and then I have to add them all up. Okay. Remember that the large number in front of the whole entire formula is called a coefficient. That tells you how many molecules that you have. This particular substance is magnesium hydroxide. The subscripts tell you how many atoms of that particular element there are in that formula, and you have to kind of watch it if you have parentheses, because for instance the O in here, there is no subscript written, but we understand that its subscript is 1. So basically if it doesn't have a subscript that's written, it's understood to be 1. But anything inside the parentheses, just like math, is multiplied by whatever subscript we have outside the parentheses. Okay, so let's see if we can get started. By the way, let me remind you that this subscript only applies to the parentheses. If magnesium had a subscript, it would be right there. But there is no subscript for magnesium. All right, well, how many total atoms do we have? For magnesium, I'm going to take magnesium's subscript, which is 1 because it's not written, and multiply by the coefficient. So that's 5 magnesium atoms. And then I need to look at my next element. And remember, every time you get to a new capital letter, you're at a new element symbol. So this is capital letter O, this is oxygen. The subscript for oxygen inside the parentheses is not written, so it's 1. And then we multiply by the subscript that's outside the parentheses, so 1 times 2. And then we multiply by the coefficient, so 1 times 2 times 5, and that is 10 oxygens. I do something similar for hydrogens. There is no written subscript in there, so I understand that the subscript inside the parentheses on hydrogen is 1. 1 times 2, and that means that there are 2 hydrogen atoms in each molecule, but there are 5 molecules, so 2 times 5, and that is 10 hydrogens. So how many atoms are represented here? Well, there's 5 of these, 10 oxygens, 10 hydrogens. 5 plus 10 plus 10, that gives you a grand total of 25 atoms. Okay? You always need to pay careful attention to what the question is asking. Here's another about total atoms, but then this one switches and asks about the number of elements. How many total atoms are in this compound? Well, the coefficient is not written, so I know that there's only 1 molecule. There's no parentheses either, so this one's going to be fairly easy. There's 12 carbons, 22 hydrogens, and 11 oxygens. 12 plus 22 is 34, and 34 plus 11 is 45 total atoms. Here, we're asking how many different elements are present in this compound. Basically, how many different chemical symbols do you see? Well, I see copper, Cu, and then I hit the next capital letter, which is C for carbon, and then another capital letter, so that's an O for oxygen, and then I see another O, but I'm not going to count it twice because I've already listed oxygen, and then I see capital H for hydrogen. So that's 1, 2, 3, 4 different elements from the periodic table. On this next one, NH4NO3, it's asking you how many molecules of this compound are there. Well, the number of molecules is written with the coefficient in front. There's not a coefficient written in front of this one, so there's only one of them. I don't write coefficients of 1. Okay, so there's only one molecule. This is ammonium nitrate. Okay, if you ever run across something like this, please pay attention. Nitrogen is listed here and here, so you would have to figure out how many nitrogens are here and how many nitrogens are here, and add them up if somebody asked you to find the total number of nitrogens. Same thing up here. There are 3 oxygens here, and then there's 1 times 2 more over here. You'd have to pay attention that they are listed in 2 different places if somebody asked you the total number of oxygens. All right. I'm going to skip down here. I want to do number 6 real quickly. C17, H18, F3NO. How many total atoms? Well, a common answer here is 38, and 38 is incorrect. How do you get 38? Well, you're zipping along and you just say 17 plus 18 plus 3, and that's 38. And you don't count the 1 nitrogen and the 1 oxygen because you forget all about them because their subscripts are not written. But they're still there. There's only 1 nitrogen and 1 oxygen. So instead of 38, you have 40 individual atoms. Okay? So that's just a brief refresher on how to count atoms. Next, we're going to look at recognizing whether chemical equations are balanced or not. Remember, the state of Texas doesn't expect you to know how to balance chemical reactions at this age as 8th graders. They just expect you to be able to recognize whether it is or not. And that's a big difference. I mean, like, I can recognize whether my car is broken or not, but I do not have the ability or the skills to fix the car. So I can recognize if it's working, but I can't fix it. So you guys, all you have to do is recognize whether the chemical equations are balanced or not. First of all, a brief refresher. On the left-hand side, the things that you begin with are your reactants. The substances that are formed in the chemical reaction are your products. The arrow means the word yields, which is pretty much saying produces. These two things produce these 2 products, okay, in a chemical reaction. All right, this is sodium chloride and silver nitrate producing or yielding sodium nitrate and silver chloride. Is this equation balanced? Well, everything has to be the same on both sides. You have to have the same number and the same type of atoms on both sides. I have 1 sodium here and 1 sodium here. That bell is not for y'all. Okay, I have 1 chlorine here and only 1 chlorine here. So I'm good so far. 1 silver and only 1 silver on the product side. 1 nitrogen on the reactant side, 1 nitrogen on the product side. 3 oxygens on the reactant side, 3 oxygens on the product side. So everything is the same on both sides. This one is balanced, and so it follows the law of conservation of mass, which says you can't just like create or destroy matter. Okay. Down here, I have 2 molecules of hydrogen and 1 molecule of oxygen producing 2 molecules of water. All right, I've got 2 times 2 hydrogen. I've got 4 hydrogen on the reactant side. 2 times 2. 4 hydrogen on the product side. There's a subscript of 1 on this oxygen. 1 times a coefficient of 2. I have a total of 2 oxygens on the product side. And a coefficient of 1 times a subscript of 2. I have 2 oxygens on the reactant side as well. So this one is also balanced, and it follows the law of conservation of mass. Down here, I'm just bopping along. 1 potassium, that looks good. 1 chlorine, that looks good. 3 oxygen on the reactant side and only 2 on the product side. So even though I have the same types of atoms on both sides, I do not have the same number and types of atoms. So this one does not follow the law of conservation of mass. This equation would need to be balanced. And it does not follow the law of conservation of mass because I can't just magically lose an oxygen atom. It's got to be somewhere. Okay. Just a couple more things about law of conservation of mass. I don't know if you guys remember this bell work from way back when, but I gave you this situation where you had copper powder being heated and all of a sudden you had copper oxide, and it appeared that you just magically had mass gained from nowhere, but you didn't. What happened was you had copper reacting with oxygen gas from the air to form that product. So every once in a while you'll have a chemical reaction where either something reacts with molecules in the air, or one of the products is like a gas that gets given off and bubbles up into the air and you lose track of it. So sometimes it doesn't seem like it follows the law of conservation of mass, but if you have a situation like this, it still does. If you're either pulling gas from the air or giving gas off into the air that's not measured. Okay, so just a little reminder. Also, last little tidbit, remember that there are certain pieces of evidence that a chemical reaction has taken place or a chemical change, and they can be color change, odor change, temperature change, gas bubbles, and the formation of a precipitate, which is an insoluble substance that kind of settles out in a container. All right, so with that, you are ready to go on your last little worksheet tidbit before our test.